Hey guys, welcome to question MM426 of the Maths Methods Fortify study guide. Now in this question, Mike loves to play 10-pin bowling. He's quite the player, and in one particular game of 10 bowls, he has a 60% chance to achieve a strike on any given bowl. Part A, which is a 1-mark question, says what is the probability that he scores 0 strikes in this game? Awesome. Well, if he has a 60% chance to score a strike, that means he's got a 40% chance to not score a strike. Okay? Right? So if he's got 10 bowls, and he's got 40% chance on each one of these bowls to not score a strike, that means that the probability that he doesn't score any strikes is equal to 40%, so 0.4, to the power of how many bowls he has, 10, right? Because he's got 0.4 chance in the first one to not get a strike, then in the next one, 0.4, next one, 0.4, next one, 0.4, and so on up until his 10th bowl. And what this means is that his probability that he gets 0 is 0.0001. So he's got a very small chance not to get a strike. Now that's our first and only mark. So let's move on to part B. Part B says, what is the probability that he achieves at least 5 strikes in this game? Now part B is a 2-mark question. And first thing we need to recognize is that we're dealing with binomial probability here, okay? So each of these strikes is independent of the other strike. Whether he gets one doesn't affect the next one. And he's got a certain number of bowls and a probability for each of those strikes, which tells us that it's binomial, okay? So what we need to do is pull out our binomial CDF calculator. And it's going to ask us for 4 things: lower, upper, N, and P. Now our lower, we're looking for the probability that he achieves at least 5 strikes in this game, okay? So part of our probability is he could achieve 5, 6, 7, 8, 9, or 10, right? So that means that our 5 is our lower bound, and our 10 is our upper bound. N is the number of bowls that he has, which is 10, and P is the chance to achieve a strike, which is 60%, so 0.6. This is our first mark. Now plugging this into our CAS, we get the fact that x is greater than or equal to 5 is equal to 0.8338. This is our second and final mark for part B. So guys, that's it. If you have any questions, let me know. But for now, let's move on to part C. Part C is a 3-mark question and says, Mike plays a second game of 10 bowls during which he is not feeling well. He does not have a consistent strike rate during this game. The success of his second game depends solely on the success of his previous game. If Mike scores at least 5 strikes in his first game, then the probability that he scores at least 5 strikes in his second game is 2 in 3. If he scores less than 5 strikes in the first game, the probability that he scores less than 5 strikes in this second game is 1 in 4. What is the probability that Mike scores at least 5 strikes in his second game? Alright, awesome. So first things first, we want to use a tree diagram, okay? Because we've got this conditional probability going on here where something is affecting something else, which means that we always want to draw a tree diagram in this situation. So what affects the next thing is his first game, right? So his first game affects his second one. So if he scores greater than or at least 5 strikes in the first game, then he can score at least 5 in the next game or less than 5 in the next game, okay? And same here. So if he scores less than 5 in the first game, then he can score greater than or equal to 5 in the next game or less than 5 in the next game. Now, we know that the probability that he scores greater than or equal to 5 in the first game is 0.8338. We found that in the previous part. So this is probably the trickiest part of this question, is remembering that and recognizing that. Which means that the probability that he gets less than 5 is 0.1662. Awesome. Now, if he scores at least 5 strikes in the first game, he's got a 2 in 3 chance to score at least 5 in the second game. Which means he's got a 1 in 3 chance to not score it. Or to score less than 5, I should say. If he scores less than 5 strikes in the first game, he's got a 1/4 chance to score less than 5 in the second game. Which means he's got a 3/4 chance to score more than 5, or equal to 5. Awesome. Excuse me. Now, this is our first mark. And we now need to figure out what probability we're dealing with. So we're looking for the probability that he scores at least 5 strikes in his second game. Okay, so we get to this path and this path, right? So we're going here and then here, or here and then here. Okay, so here is at least 5 and here is at least 5 as well. So we're looking for both of these probabilities. So the way that we do that is by using these probabilities. So 0.8388 times 2 and 3, yep, plus 0.1662 times 3 and 4. Awesome. And these are the only two paths that can result in him scoring more, at least 5 in the second game. So these are the only ones we know. So that's our second mark. Then we can use our CAS to find this. So 0.5558 plus 0.1247. And this is equal to 0.6805, which is our third and final mark. So guys, that's it for part C. Let's move on to part D. Part D is a 2-mark question. And says, I'm actually just going to get rid of this. So if you want that, just write it down. So part D says, suppose Mike scores at least 5 strikes in his second game. What is the probability that he scores less than 5 strikes in his first game? Awesome. So essentially what we're saying is, what's the probability that he scored less than 5 in his first game? Given that, or maybe 1, given that he scored at least 5 strikes in his second game. Okay? So that's probably the hardest part to kind of recognize, is this is a given formula. So it's told us that he scores at least 5 strikes, which means that's our given. So the probability that less than 5 in his first game intersect at least 5 in his second over the probability that he scored at least 5 in his second. Awesome. So that's really our first mark, recognizing that. So the probability that the intersect between less than 5 in his first and at least 5 in his second is our pathway, at least less than 5 in his first and at least 5 in his second. Okay, so we need to get this probability. That's our intersect. So the way we find the intersect is by multiplying these two together. We get 1,662 times 3 and 4 over the probability that he scores at least 5 in his second game. And in the previous part, we found that that probability was 0.6805. That was the probability that he scores at least second in the second game. Sorry, at least 5 in the second game. Cool. And now we can just plug this into our CAS and we get 0.1247 over 0.6805. And this is equal to 0.1832. And that's our second and final mark for part D. Guys, that's it for this one. Let's move on to part E. So part E is a 2-mark question. And it says, Mike uses a specific brand of bowling balls. The weight of a ball X kilograms made by this brand is a normally distributed random variable with mean 6 kilograms and standard deviation 200 grams. Let Z be the random variable which follows the standard normal distribution. Awesome. So, the question says, find the value of K such that the probability that Z is less than 1.4 equals the probability that X is greater than K. Awesome. So, what we're looking for is probably that Z is less than 1.4, which is our standard normal distribution. So here we're 1.4 standard deviations away from the mean. And then we're trying to say that this is equal to the probability that X, our value here, is greater than K. Okay? So we're saying that this bit here is K. And because of our symmetrical properties, we're saying that this is the probability that X is greater than K. Okay, so these are the same probabilities, just going the opposite way, and because these are the same distance away. So firstly, we have to figure out what our X value is at this point. Okay, so we need to figure out how far away from 6 we are at this 1.4. So we can say that our Z and X values are linked by this formula. We know that our Z value is 1.4. We're looking for our X value at this point. We know that our mean is 6. And we know that our standard deviation is 200 grams, which is 0.2 kilograms, right? Because we need to make sure that we're in the same units. Awesome. From here, we can say that X is equal to 6.28, and that's our first mark, okay? So we know that here, this is 6.28. Now, if these are symmetrical about the mean, which they are, that means that this 6.28 must be the same distance away from 6 as is K, okay? So from here to here is 0.28, which means from here to here is 0.28. So K has to equal 5.72. Cool. Which means that our K value is 5.72. And that's our second and final mark. Guys, if you have any questions about any of this, please let me know in the comments below. If you had 5.82 in your solution, that's actually been a typo on our part. So the real answer is 5.72. So that's it. Let's move on to part F. The part F is a 1 mark question and says 70% of these balls are heavier than X kilograms. Find the value of X corrected 2 decimal places. Cool. So let's actually just get rid of this as well. We can say that 70% of them are heavier than X kilograms. So let's call this X here. And we're saying that 70% of them are heavier than that, right? So when we know our probability or we know our area, we immediately want to go to our inverse normal function in our CAS, which in my case is menu 553. And it's going to ask us for 3 things: area, mean, and standard deviation. Cool. So we know our area, we know that, excuse me, we know that that's 70%. But when we're dealing with inverse normal, we always need to take the area to the left of the point that we're dealing with, okay? So to the left would be 30% because to the right is 70. Everything has to add to 1, which means that our area is 0.3, right? Our mean is 6, and our standard deviation is 200 grams, which is 0.2 kilometers. Awesome. Now what this spits out is X equals 5.90 kilograms. And that is our first and final mark for part F. Part F was a 1 mark. And that's it for part F. Let's move on to part G. Part G is a 2 mark question and talks about confidence intervals. So it says a sample of 220 balls are weighed, 220, and 170 weigh less than 6.2 kilograms. Awesome. The brand is 95% confident that between A% and B% of all manufactured balls will weigh less than 6.2 kilograms. Awesome. Find the values of A and B correct to the nearest whole number. All right, awesome. So in order to find a confidence interval, we have to use our confidence interval formula, which is p hat minus z, square root of p hat minus 1 minus p hat over n, p hat plus z, p hat 1 minus p hat over n. Awesome. And now we just need to sub our values in to get our confidence interval. So our p hat is the proportion of balls that weigh less than 6.2, okay? So in this case, we know that 170 of them do, and we had a total of 220 balls. So our proportion is 170 on 220. Minus our z value, which comes from our 95% confidence interval. So with a 95% confidence interval, our z value is 1.96. Okay, so that should be kind of known knowledge. Now p hat again is 170 on 220. And then 1 minus 170 on 220 over n, which is 220. That's our lower bound, and then our upper bound is 170 on 220 minus plus 1.96, 170 on 220, 1 minus 170 on 220 over 220. Awesome. That's our first mark. Sweet. Now, I would sub this all into my CAS, and what you would get is 0.717, 0.828, which is 72% to the nearest whole number, 72% and 83%, which therefore means that A is equal to 72 and B is equal to 83, right? Because we had A% and B%, so that's our final answer. And that is our second and final mark for part G, and that actually wraps up MM426. So guys, if you have any questions about anything in this question, please hit me up in the comments below as always. But otherwise, thank you very much for watching, and I'll see you in the next video.